Here's your lecture for pre-calc. It's lesson 11.2.1, graphing complex numbers. So I feel like you might already know this, but when you graph the imaginary numbers, you use the real part goes on, see how they wrote the axis? It goes on the horizontal axis, and the imaginary part goes on the vertical axis. So something like this would just look like 4 comma negative 5. So I went 4 negative, oh, I didn't do it, they did it. So there it is. So here's some new vocabulary for you. The modulus is actually, well, we'll read what it says. The modulus is the distance of the complex number from the origin in the complex plane. So it's this distance right here, if we're talking about that. And we use absolute value bars to show that we're talking about the modulus of a complex number. And interestingly, it just ends up being, you can get the modulus, well, I won't spill the beans. We'll talk about that in a minute. The argument is the angle between the positive real axis and the vector representing the complex number. So we don't denote this as arg. Hey, somebody wanted us to say arg. Arg A plus BI. So the argument on this one would be, well, I mean, it could be an angle measure, but I would probably find this little angle measure, and then I would subtract it, or I could say it's, well, yeah, I would subtract it from 360. So anyway, so the modulus is kind of like a distance, and it can actually be viewed as the hypotenuse of a triangle if you draw a little triangle, a little right triangle on the x-axis, and the argument is an angle measure. Okay, so they want us to plot. I'm not going to do all of these. I'm going to try to, I don't know if I can do this in 10 minutes, but I will try. So plot each of the complex numbers. So negative 3 plus 4i would just be shown as negative 3, 1, 2, 3, comma 4, 1, 2, 3, 4. So I've already got it plotted there. And then they want the modulus. So the modulus is just, it's just this little, I'm going to think of it as a hypotenuse of a little right triangle. And so really I am going to actually make the right triangle, and I'm going to say 1, 2, 3, and this is 1, 2, 3, 4, and I could use Pythagorean theorem. Oh wait, I think I did it right here. And I could say 3 squared plus 4 squared equals c squared, and I ended up with 5. Okay. And then if I want the angle measure, I'm going to get the angle measure from the positive x-axis. So really, if I just think of it as a right triangle, it's going to make it a lot easier. I know that's opposite over adjacent. Tangent is opposite over adjacent. So I know this is 1, 2, 3, 4, and this is 1, 2, 3. So I think I'm just going to take the inverse tangent of 4/3, and that's what I did here. And I got 53. Because that's for this angle right here, but I know that we count our angles from the positive x-axis. So what I really want is this arc I'm drawing right here with my pencil. So I know that this arc plus my little 53 adds up to 180. So I'm just going to say 180 minus 53, and that should give me my, well, we're going to call it argument. So modulus is the hypotenuse of the triangle, and argument is the angle measure. Alright, so we're on 11-82, and they're asking us, how can the distance between two complex numbers be calculated? First, consider two real numbers. So if I have two real numbers, you just go like, you can go 5 minus 1, because the distance is 1, 2, 3, 4, or you can go 1 minus 5, that would be negative 4, but you just take the absolute value. So they wanted us to say n minus m. Now it says let's take this complex number u and this other one v in the complex plane. What's the distance between them? So I just actually put them in the complex plane. I think I had a picture of them already. I know, I drew a picture of them right here. So I want u minus v. So I just drew both of them, and I came up with 2 minus 6i. We're on letter C. Letter C. Oh no, it said evaluate them. So I evaluated them. U minus v. So there's u, there's v, there's a minus sign. I had to distribute it, and I had to combine like terms. That's how I got that. And then letter D said, what's the modulus? So the modulus ended up being root 40, and I just made a little triangle, and I did the Pythagorean theorem on it and got it. And then letter E says, given two complex numbers u and v, write an expression to calculate the distance between them. Well, it's going to be the absolute value of u minus v, or the absolute value of v minus u. It's just like we just don't want a negative number there. And then how's your expression in part E related to the expression you wrote for the distance between the two real numbers? Why is it true? The expressions are the same because every real number is a complex number. Alright, so how can we find the midpoint? How can the midpoint of two complex numbers be determined? First, consider two real numbers m and n and write an expression to calculate their midpoint. So I don't know if you already had this. I already knew this, like I had it memorized, that it was m plus n over 2. I drew a number line, and I said, well, how would I find the midpoint between them? Like, I could just go like that. Let's see. So I guess right here would be the midpoint. It's 3. But how would I do it? You don't just go 5 minus 1. Well, you could go 5 minus 1 and then you would add 1. It gets a little complicated. So basically what you're doing, though, is you're going to go 5 plus 1, or 1 plus 5, and then take half of that. And it actually works out, because that accounts for the fact that you didn't start at 0. So it's m plus n divided by 2 is how you do that for the midpoint formula. Again, let u equal okay, we got the same vectors we were using before. Where's the midpoint of those two vectors? Well, I think I can add them together and divide by 2. So I'm going to add them. Oh, I did it over here. I added them together. Like that was one of the vectors, and that was the other one. I divided by 2. And I got that. And I could also do it this way graphically. I just looked at the graph, and I found that it was, on the graph, it was 4, -1, but we know that we're counting the y-axis as the imaginary numbers. I'm gonna have to make another part 2 because I ran out of time.